In question 2, we're going to let v equal dx dt. So dv dt will be the second derivative, d2x dt2, and dv dt, d2x dt2 is dx dt to the squared, so dv dt, which is this guy, is equal to v squared. So dv over v squared is equal to dt, and if we integrate these, we're told that dx dt, which is v, is equal to 1, so v is 1 when t is 0. V squared is v to the minus 2, so we end up with v to the minus 1 over minus 1, which is equal to minus 1 over v. So minus 1 over v between v and 1 is equal to t between t and 0. So we're going to get minus 1 over v minus 1 over 1 is equal to t minus 0. So 1 over v, if I bring it to the right, will be equal to 1 minus t. So we can invert these fractions to get v is going to be equal to 1 over 1 minus t. So we have dx dt now, which is v. Dx dt is equal to 1 over 1 minus t. Just be careful with this 1 over x. When it's a minus, it's going to give a minus in here. So dx is equal to 1 over 1 minus t dt. So if we integrate these, we're told x is 0 when t is 0. We're going to get x on the left between x and 0, and on the right we're going to get minus this minus 1 over 1 minus the natural log of 1 minus t between t and 0. So we're going to get x minus 0 is equal to, putting t in, we get minus the natural log of 1 minus t, and then putting 0 in, we get minus the natural log of 1, which is equal to 0. So we can cancel. So we're going to get x is equal to the natural log of 1 minus t to the power of minus 1. This minus 1 will go up as a power. So that's x is equal to 1 over the natural log of 1 minus t for question 2. I should actually write it as the natural log of 1 over 1 minus t. My bad. Natural log of 1 over 1 minus t. For the end of question 3. Question 2.